Alright, ladies and gentlemen, welcome to video 4 of 5 for Chapter 4, Section 3 in your Algebra 2 textbook. This will be a very short video as it is discussing a specific special case type of factoring called difference of two perfect squares. So to recognize the difference of two perfect squares, first of all, we are looking for a binomial. That binomial must have a subtraction sign in the middle. We want to have already factored out the greatest common factor. And essentially what we're looking for is that this binomial will factor into what are called conjugate pairs. So you'll end up with a minus b times a plus b if your original function is a squared minus b squared. So one thing that's helpful to have here is a list of the perfect squares, which would be your numbers that have exact square roots. So here are the first, I don't know, we'll go about 20. Uh, 324, 361, and 400. So there's the first 20 perfect squares. So you may not know those numbers, but you definitely need to recognize that those are numbers that have an exact square root. So if we look at example A and we're asked to factor that expression, we should realize that x squared is a perfect square in that its square root is x, and 100 is a perfect square, its square root is 10, which means that that factors into x plus 10 times x minus 10. Now the reason why this works is because essentially we do not have that middle term. So we're looking for two numbers that multiply to negative 100 and add to 0, which would be 10 and negative 10. Okay? So on the next one, the square root of 9x squared would be 3x. So the first term in both sets of parentheses is 3x. One is a plus, one is a minus. And the square root of 49 is 7. On letter C, you'll need to factor the left side first and then use the zero factor theorem to solve. So go ahead and pause the video and try it on your own, and then resume the video to see how you did. X squared minus 64 factors into x plus 8 and x minus 8. Because the square root of 64 is 8, the square root of x squared is x. We would then break those up into two separate equations, x plus 8 equals 0, or x minus 8 equals 0, which would give us our solutions of x equals negative 8 or x equals positive 8. On letter D, we would need to factor that. It is again a difference of two perfect squares. The square root of 25x squared is 5x, so our first term in both sets of parentheses is 5x. One is a plus, one is a minus. The square root of 144 is 12. That equals 0. So again, we're going to break that up. We've got 5x plus 12 equals 0. And we've got 5x minus 12 equals 0. Our solution is one of those two equations. So we are going to subtract 12 from each side, or add 12 to each side, which would give us 5x equals negative 12, or 5x equals 12. And then we are going to divide by 5 in both equations to get x by itself, which gives us x equals negative 12 fifths, or x equals positive 12 fifths. That is how we carry out the difference of two perfect squares. We got one more video to go for this lesson. Thank you very much for your time and attention.